hands up. And so let's see how we're doing with standard form. What standard form equation would work for this scenario? Start with Sharif, Zabari, and then Hezekiah. What'd you get?
4.50x plus 6y equals 108.
Okay. Okay.
4.50x plus 6y.
Okay. So they all agree, and I do agree as well. Oops, excuse me. I do agree as well. Anyone see any issues with that though? Any issues? Shelby, Brandon, Brian, Shelby? Yeah, what were you going to say, Brandon? Yeah, so even though this is perfectly acceptable because we are talking about a real world scenario, there would be better ways to write this. Did anyone convert it so that it was truly in standard form? Go ahead, Maria, what did you put? Okay, so you just converted it to a different form. That was a good idea. Brian? How did you achieve that? That was a beautiful explanation. Very good. So it could be 40, you multiply the whole thing by 10, 45x plus 60y equals 1,080. You also could have, so you could have had a whole bunch of different ones. You could have multiplied the whole equation times 2. We talked about getting rid of decimals by, by halves by multiplying the whole thing by 2. Brandon?
3x plus 4y equals 17.
That's right. And that is another way to express it. Very, very good. Now, graphing. So now we're reaching back into chapter 4 to what you already know. And this is what your graph should have looked like. Just by looking at my graph, can you tell what method I used to graph? Raise your hand and wait to be called on. What method do you think I used to graph? And? You think I used slope-intercept form? What do you think, Catalina?
I think you use
Intercepts? Okay, what do you think, Alyssa? Okay, well, what made you think slope-intercept form? You thought it was the easiest, okay. Why did you think intercepts?
because you have a 2-point outline.
Ah. So you can see the intercepts, I graphed them right here. So you're right, slope-intercept form is very easy, I think. But when an equation is in standard form, it's very easy to find the x and y intercepts. And so looking at my graph, the clue is right there, that I have the x and y intercept and I just connected them with a line. Okay? You can use any method you want. I don't really care, but I think that was the easiest. Now, number 3, combinations. Someone give me a combination that will work. Got lots of people with combinations. We'll start with Tristan, and then Kayla, and then Alicia. What do you have, Tristan? Okay. 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 How can I find out if their combinations will work? Because I don't have a list of all of them. How could I find out if their combinations will work? Kamoy? Very good idea. I could plug them in. So Kayla, you said yours was 4, 15. So that's 18, and that's 90. So that will work. I could do mental math. Is there another way to tell whether or not their combination will work? Let's use Kayla's as an example. Is there another way for me to tell if 4, 15 will work? Got some people who think they know. Jada? Yeah, look at it on the graph. So go to 4, comma 15, if that is an exact point on the graph, then I know that it will work. If it is not an exact point on the graph, then it will not work. Very good. So, there are a whole bunch of different combinations. So here are a few, the ones that they said were all good as well. So now it's kind of funny that my plan completely backfired. I had this great plan and it completely backfired. Ms. Mitchell did me a favor and gave you guys a question, and I see you guys all have it out. In fact, I think many of you finished the warm-up in a nanosecond because you already did it in Ms. Mitchell's room. My plan backfired. That's not what I was hoping you were going to do. So I guess this is what I should have written. I should have written, T-shirts at the flea market cost $4.50 each, and shirts cost $6 each. You had $108. List all the possible combinations of T-shirts and shorts you could buy for exactly $108. You may not use algebra or graphing to do this. That's what I should have written. So what I was hoping you were going to do was sit there and try and calculate all the different combinations by testing them one by one. So I don't know what happened. I don't know if you guys worked together, which is totally fine. I don't care how you did it. I'm just completely shocked at what I see. I'm walking around, I see a lot of people have it out already. And it's amazing that a lot of you have exactly what is up here, and you did it without me prompting you or without me asking you. Which means that you figured out the more efficient and effective way of finding all of the combinations. How many combinations are there that will come out to exactly 108? There are 7. And only 7. So there are lots of combinations on, there's lots of combinations of T-shirts and shorts, but there's only certain ones that will come out to exactly 108. Now, any point on this line will also get you the number of T-shirts and the number of shorts. But there are certain points that don't count. For example, this point right here would be 11.5 pairs of shorts. You can't have a half a pair of shorts. So that point doesn't count at all, okay? So I'm pretty impressed with you guys. I'm also a little angry that you guys totally butchered my plan. But I guess it's my fault. Next year I'll be a little smarter about it. So I learned a lot from you guys today. So this warm-up is a reflection of everything we've been studying. It's a connection, the graph, the equation, understanding what a combination is. Okay? Are there any comments or questions on what we did here or why I gave you that question earlier in the day? Good. Put the warm-up to the side. Today we're going to be studying parallel and perpendicular lines and how these two types of lines relate to what we've been studying so far. For the past couple of weeks, we've been exploring different ways to write equations of lines. Based on different circumstances, such as having one point and a slope given to you, you are now able to write an equation of a line, not just in one way, but in 3 different ways. And hopefully you've developed the understanding that all 3 ways really mean the same thing. It's just different ways of representing it. So today we're going to start exploring different ways to use this type of information. We're going to start with parallel and perpendicular lines, and then next time we're going to start exploring a more real world, an even more real world idea of having a scatter plot and developing a line of best fit. So the first half of the chapter was developing the skills. The second half of the chapter is utilizing the skills. Okay? So first, I provided you with this graph already, so you don't need to draw it. So if you would have it out in front of you. So could I have some volunteers try to think about the picture and just give us an idea of what it is that we're looking at, and then we can work from there. Sebastian, what is it that we're looking at? I'm sorry? 2 lines with the same slope. How do you know?
They all have the slope of rise to.
Okay, so you actually calculated the slope in your mind, and then you said that they have the same slope. So you can actually prove it. Okay, well, we'll see if you're right. Zavari?
There are 2 lines that have the same slope but different
Y starting points. What is that called, really? B, very good. It also has another name. What is it? Y intercept. Very good. Shariq, what do you see?
They're parallel.
Parallel. Okay. They look parallel. Can you prove that they're parallel?
Well, if they're parallel, then they're pointing in the same direction. And if they're pointing in the same direction, then they have the same steepness.
Same steepness.
Or
Okay.
slope, like Sebastian proved.
Very good. So, but we don't want to just look at a picture and say they look parallel. We do want to be able to prove it. So you're going to be writing directly on your copy. I'm going to be writing up here. We want to prove it. What we do know is if they are parallel, they will have the same slope as Sebastian said. So to figure it out, we just need their slopes. What's the easiest way to get their slopes from this picture? What's the easiest way to do it? I like efficiency. I want things to be quick. Catalina? Rise over run. Find 2 points on the line and do rise over run. So I'm going to pick that point and that point. And then I'm going to do rise and run. And so I rose 1, bless you, and I ran 2. So the slope is 1 over 2. So what about the green line? Well, I have a point here, and I have a point here, and I can do rise over run, and I'm going to quickly see, well, I got almost the same exact picture as Zabari said, it's just at a different y-intercept. And so I end up with the slope being 1 over 2. So by comparing their slopes, I can now, prove that they are parallel. Are there any questions or concerns or comments about that? I also love how Shariq brought back a word from the beginning of our study of slope, way back in chapter 4, that we're talking about steepness. How steep are these lines? That was excellent. So this is actually a review. We studied this before. That's how Sebastian knew what he was saying. But now, what about this picture? What are we looking at now? What are we looking at now, Tristan? Lines intersect. Very good. Anyone, what else? Alyssa, Ann, and then Brian.
Their slope is the opposite. It's the reciprocal.
Okay. Okay. How'd you know that? You read ahead. Very good. Smart. I asked her to, but that's pretty smart. Oh, perpendicular. So, but isn't that what he said? He said they intersect. Isn't he?
Perpendicular is when the lines intersect at a 90-degree angle.
Oh. So, intersecting is good, but that's not enough. How do you know that these 2 lines, this blue and this orange line, how do you know they're intersecting at a 90-degree angle? I mean, I don't know. How do you know it's 90 degrees? Alicia?
Because you have a box with the right angle.
Yeah, usually in a geometric picture, if you see this, that indicates that there's a 90-degree angle. So I am basically telling you, by drawing this, I'm telling you that these are 2 perpendicular lines. Tristan was right, they are intersecting, but that's not enough. You have to be able to say that they're perpendicular. But now let's look at their slopes. So let's start with the blue line, and we need to find 2 points on the line, and let's see. I got a point here, and I got a point, this looks like the next friendly point. So let's find the slope of the blue line. So we'll do rise, run, and so it's rising 2, and it's running 3. So the slope of the blue line is 2 over 3. So Alyssa, you said you thought that the slopes were going to have some relationship to each other. What was the word you used?
It's
The reciprocal. So you think that when we figure out the orange one, it's going to be the same as this except flipped? Okay, so let's take a look and see if that happens. Because this is covering this, I'm going to erase this just for a moment so it's not too confusing to look at. So now we want to explore the orange line. So let's find 2 points on that line. Looks like I have a nice friendly point right there and right there. And let's rise. And then we're going to run. So we rose 1, 2, 3. We ran to the left, so that's a -2. So the slope was 3 over -2. So what do you think? Was Alyssa right? What do you think?
No.
Tamoy?
She was wrong because it's not the reciprocal because that one's
Oh. Okay. I mean, was she like completely way off? Was like her answer the most horrible thing in the world? So there was a detail that was missing.
Yeah.
Okay. Good. But if I took away this negative, then Alyssa, oh, excuse me. Let's see if I can grab that. If I took that away, then Alyssa, you would say that those are reciprocals. Okay. But there is a negative there. So we do have a name for this. If you read the book already, which I asked you to do, then you already know the name. But this is called negative reciprocals. And so that's what we're going to talk about today in addition to parallel. Go ahead, Brian.
What if the slope of the regular line is negative, and if you use negative reciprocal, you get confused and keep the other slope?
We're going to talk about that in a moment. Okay? So, the idea here was to see it in action, to see the relationship of slopes when you have parallel lines and the relationship of slopes when you have perpendicular lines. And this will be true no matter which perpendicular lines you have, whether they're here or whether they're all the way over here or down here. If they're perpendicular, their slopes will have this relationship. So let's put this into words. First of all, parallel you already know, so you don't need to copy that down. You know that if you have 2 parallel lines, the slopes are the same. Also, if the slopes are the same, then that means the lines are parallel. But what about perpendicular? How does that come out in words? They're perpendicular if their slopes are negative reciprocals. But Brian's pointing out there's a little bit of a strangeness to the phrase negative reciprocals. So I actually don't like it, and that's why I add this little disclaimer. Negative really means opposite. Because when you think negative, that means it's always negative. It's not always negative. It means the opposite. And then I kind of break it down into layman's language, which means kind of just plain language. Flip the sign, flip the number, flip the sign. So if you have a slope and you need to know the perpendicular slope, you flip the number, flip the sign. That will give you the opposite reciprocal. So before we start using these ideas heavily, let's just explore the concept of opposite reciprocal so we're comfortable with it, and then we'll move forward. So, if I have an original slope of -5, and I want to know the perpendicular slope, or the negative reciprocal, what will it be? Flip the number, flip the sign. Flip the number, flip the sign. Put your hands down for a second. I want to give everyone a chance to set up their paper. Don't go bonkers making a perfect table. It doesn't need to be perfect. Just a simple table. You can use abbreviations. So, again, original slope is -5. Brandon, what will the negative reciprocal be? 1/5. Very good. For those of you who have trouble seeing stuff like that, you have to remember that all numbers have a 1 underneath. And so when I say flip it, the 5 is going to the bottom, and the 1 is going to the top, and then we flip the sign. So it was negative here, which means it will be positive here. Any questions about that? Okay. What about 4/7? What will the negative reciprocal or opposite reciprocal be? Hezekiah? Very good. -7/4. And remember, a negative fraction. The negative sign can either be in the middle, on the top, or on the bottom. It doesn't matter. They're all the same. Okay? Any comments or questions so far? What about -1/8? What will that perpendicular slope be? Kayla? Very good. I love the way she said +8 to be really clear about that. Yeah, +8. And what about 14? What will the negative reciprocal be of that? Shelby? Very good. -1/14. Does anyone have any questions about that?
What if it was a whole number? Do you convert it in a number? Wait. Oh wait, never mind. Never mind.
You sure?
Yeah.
Okay. Any other comments, questions? So now we're going to use this idea with some concepts that we already know. Remember that the entire chapter is about writing equations. So all I'm doing today is introducing new circumstances, new scenarios, but the goal is still the same. It's going to be a little bit more complex today than it has been. It's going to take your brain a little while to wrap itself around the idea. So, example 1. So we're still writing an equation. That's what we've spent the last 2 weeks studying, writing an equation. Today, because the publisher and I actually are in agreement, we're going to be using slope-intercept form the most. So you still know standard form, and you still know point-slope form. We're going to see equations in standard form a lot, but when we write our equation, we're going to write them in slope-intercept form. So there was a guide that I asked you to set up when we were learning how to write equations in slope-intercept form. There was one for slope-intercept form and there was one for point-slope form. They were similar but a little bit different. So what was the guide that I asked you to set up? Jada? Yeah. We need the slope and we need the y-intercept. Once we have those two pieces of information, then we can write an equation of the line in slope-intercept form. Here's where things get a little muddled from my experience with my students. My students with these questions get lost on what they're doing. I'm telling you, it happened this morning with another class. I mean, it's very difficult to keep track of what it is that you're actually doing. So when you set up this key right away, when you see that you're going to write an equation, and you decide what form to write it in, then you set this up right away. This keeps you focused. Okay, now let me explain what's going on here. We are being given a line. That is an equation of a line. Here is a separate point. This point is not on that line. How do I know? Because that's the situation. This point is not on this line. Here's what we are used to. We are used to this situation. I have to white some things out real quick. We are used to being given not this. We're used to it saying something like m equals, I don't know, 3/5. And then you're given a point and you're asked to write an equation of a line. If I asked you to write an equation of the line with that information, you guys should be able to do it, no problem. And you should be able to do it in slope-intercept form, point-slope form, or standard form. But now, instead of being given the slope, we're being given the slope hidden. It is hidden inside here. So the whole purpose of this piece of information is just for us to find the slope. It is just for us to get this piece of information. That is its sole purpose. Okay? So, that's what we're going to do, is we're going to find the slope. So, how can we get the slope from this? We've got a bunch of people who know. There's more than one way. Maria, how would you do it?
I would take 6, like, before the standard form, like A over B.
However you want to do it.
So it would be -6 over -2.
Very good. So we could use our knowledge of standard form, and we know that the slope is the opposite of A, so the opposite of 6, over B. And then what does that simplify to, Maria?
B3.
3. Very good. So we know that the slope is 3. Kamoy, what were you going to suggest us do? You were going to suggest this? Was anyone going to suggest anything different? Because I would have thought of something different first.
You could put it
Into what?
into slope-intercept.
Yeah, if you rewrite this into slope-intercept form, then the slope also pops out. So if I say, okay, subtract 6x from both sides, I'll get -2y equals -6x plus 4, and then divide everything by -2. Divide everything by -2, and then I end up with y equals 3x minus 2. Either way, I can see the slope is 3. This is certainly faster. So if you understand how that works, then by all means do that. If you get confused by the -a over b, which I sometimes do, you can always resort to this. But what we've done is we've extracted the hidden slope. The hidden slope was 3. Now I need the y-intercept. But here's where students get confused about the actual question. Here's a y-intercept. It's -2. But that's not the y-intercept I'm looking for. That's the y-intercept of this line right here. I'm not worried about this line. I'm trying to write a new line. I'm trying to write a new line that passes through this point and is parallel to this. So you can think of it this way. One second. You can think of it this way. I am trying to find this. Let's just make this up. I'm going to pretend that the graph of this is like that. And then we've got this point over here. And so what I'm trying to find is the line that's parallel to that line. This is what I'm trying to find. This is the y-intercept of this line. I'm trying to find the y-intercept of this line. So we have a number of things that we can do to find that. So what would you do to find that? The y-intercept. Got 1, 2, 3, 4, 5, 6, 7, 8. Sebastian?
Is it already there, so it's 0?
Is it? I don't know.
It is.
It is. It's 0, 3. So how do I know that that's the y-intercept?
Because since the x-coordinate is 0, and y-intercept is just on the axis.
You are absolutely correct. So in this case, we can see it right there. So we already know that the y-intercept is 3. But let's pretend for a moment that you didn't see what he saw, because I honestly, I didn't see that. I wrote this question, I didn't see that. I didn't notice it until someone in the other class said it. So let's pretend that you're a little bit foolish like Mr. Gallick. What could you do to still find the b, even if you didn't realize that that was it right there? What can you do at this point? There was something else you were taught. Sharif?
Y, okay, y equals, well, I was thinking like you can like substitute the x and y coordinate and then like substitute the y-intercept with b, but if you didn't see that, then there would probably be no other point.
Well, no, there's a method that we learned. We learned it way back at the beginning of chapter 5. Hezekiah?
You put x1 over y1 over 0, plug the y into the 3 for y, so 3 equals 3 times 0 plus b.
Very good. That's exactly right. We use what we know. We know that y equals mx plus b. This is the b that we're looking for. And I am given this point right here. So he was right. Take the 3 and plug it in. I know the slope already, plug it in. I know the x-coordinate, plug it in. And now I can very easily solve for b. It just so happens that Sebastian was right. 3 times 0 becomes nothing, so b equals 3. But what if I didn't know that? Then I would need to do this. So, the equation of the line that we're looking for is y equals 3x plus 3. Now I have an equation of a line that's parallel to my given line. This is parallel. Comments, questions, concerns? Although I must say, you might want to let it digest for a little while before you start kind of going, what is he talking about? Hezekiah and then Sebastian? Nope. Once you use this line to get the information you need, all we needed from this was this, then we don't need this at all. In fact, I would encourage you, once you get the information you need from that line, I would cross it out so you don't get confused. Because my students tend to do this. My students tend to give me answers like that. Because they get confused about what you're actually trying to do. So you really have to keep straight now what it is your goal is. Okay? That was a very good question you asked, Hezekiah. And it was Sebastian, Brandon, and then Shelby.
Are you just solutions or isn't it something you put back in standard form?
Not today, although I did have a student in another class who was very comfortable with standard form and just kind of naturally kept putting the equations back in standard form. That's wonderful. If you can do that, that demonstrates that you are really understanding what we've been studying. I mean, that's a really high-level demonstration. Okay? But no, you do not have to. Okay? Brandon and then Shelby?
Is the real name for 6 over 2 6 seconds?
What are you talking about, man?
It says like 6, 7 over 4 or something. I didn't like to know.
I would have, you mean 6 over 2? 6 halves? So you're saying 6 seconds? I know what you mean. But no, you would say 6 halves. Shelby? Go ahead. Go ahead, Shelby. No, we did not. That was a good question. That was a good question because I might have thrown you off. I actually threw off an entire other class because I just finished talking about negative reciprocal and then we didn't do it. Can someone explain why we didn't do negative reciprocal here? Why didn't we do it, Alicia?
Because I just that.
There's a simple answer. Come on.
Because it's not, it asks for a parallel line, but no, negative reciprocal line for perpendicular.
That's right. So we are going to use it today, but it asks for parallel, not perpendicular. So I apologize if I threw you off. I'm serious. This morning I threw off, the entire class was like, wait a minute, why didn't we do negative reciprocal? So what I'm doing is I'm relating first the types of questions back to what we already know, and then I'm going to throw in the negative reciprocal after that. Okay? So let's get a little more comfortable with the process. Let's look at it again. So we're given a line, and I am asking for a parallel line. The parallel line must pass through this point, and I would like it in slope-intercept form. So to get myself focused, I can set up this so that I can focus on what I'm trying to achieve. So the first thing I need is the slope. So what's the slope of my new line going to be? Got a bunch of people who know. Catalina?
3 over 5.
It's going to be 3 over 5. How'd you get that?
Oh wait,
So
no.
fast.
Never mind. Never mind.
Why?
Because I thought, never mind.
You thought it was the opposite of A over B, right?
Yeah.
Yeah, but what's that? When you do that, that's right. What form is this in?
Like, the slope of
So it's actually even easier. So what's the slope?
Oh, 3, negative 3.
Negative 3. So in fact, there's no effort involved. When it's in slope-intercept form, boom, it's right there. Okay? But I'm glad that happened because that can show you that there's so much swirling around in our brains now that it's very easy to get confused. I don't blame her for doing that. That wasn't a big deal. But now I need the y-intercept of my new line. This is the y-intercept of my original line. I need the y-intercept of my new line. So what can I do to find that? What can I do to find that? Kayla? Very good. So I've got y equals mx plus b. I can plug in this ordered pair. So I've got 4 equals. I have the slope also, negative 3 times x is negative 1 plus b. So what will my y-intercept be? Alyssa? It will be 1. So this is the y-intercept of my new line. And so I can now simply write y equals negative 3x plus 1. And I have found the line parallel to my original line, and it passes through that given point. Does anyone have any questions or comments on how we did either of these? Questions or comments? Okay, so checkpoint number 1. Let's see how you do on your own. how we did. What is the line that's parallel to this one? And passes through 5, negative 5. We'll start with Maria, Jada, and then Brandon. Maria, what'd you get?
Y equals negative 8 over 3x plus 8 and 1/3.
Wow, that sounds like a mess. Jada? Okay, that's another mess. Go ahead, Brandon.
I have like the same as Maria, but I keep it in standard form. So 8x plus 3x plus
Equals what?
25,
25. Okay.
which is the same thing.
Okay, so that is the same thing as Maria if I can do that in my head mentally. Brian, what did you get?
Y equals negative 8 over 3x minus 18 over 3. I mean, 18 and 1 and 3.
Okay. Comes out to y equals negative 8/3 x plus 8 and 1/3.
The second time.
So, we've got our key. Give me a thumbs up if you got the correct slope. Good. Anissa, how'd you get this? Very good. Opposite of A over B, put it in simplest form, it already is, so you get negative 8/3. Excellent. Give me a thumbs up if you got the correct y-intercept. Good. And how'd you find that? Plugged into what? Okay. Into what? We plugged it into that equation up there? Very good. Y equals mx plus b. You plugged in this and solved for b. So you get y is negative 5 equals negative 8/3 times x is 5 plus b. Yeah, it's a little bit messy, but you can still do it. That's why you're in this class. And so when you do that, it comes out to 25/3 or 8 and 1/3, and then of course you write y equals negative 8/3 x plus 8 1/3. Catalina.
Can you B? I got negative, negative 18 over 1/3.
Negative 18 and 1/3. Okay. So you're not alone. There's, I think, at least 2 other people who got that. So did you have this?
Yeah.
So then it's a calculation issue. What does this come out to?
Negative 40 over 3.
Negative 40 over 3. Okay. So this is negative 40 over 3 plus b. How do I write this as thirds with a denominator of 3? What will that become? Zabari? Negative 15 thirds. Add 40 thirds to both sides. This cancels out. Positive 40 and negative 15 equals positive 25 thirds. Shelby? The only number that has to be improper is slope. You can make this improper or mixed number. Either way is fine. The only number that may not be like this is a slope. Okay? All right, I'm going to move on. You guys are doing well so far. So now let's take what we've just explored and then just add in the concept of perpendicular versus parallel. So again, it's the same exact instructions. Write an equation of a line that passes through that point, but perpendicular to this line. We are still going to use slope-intercept form to write our equation. So we are still going to set up this key. That helps us focus. I need a slope. So we're going to do the same exact thing we did a little while ago. We need the slope. We need to get the slope from this. So how can I get the slope from here? There's a bunch of different ways. You decide what works for you. How can we get it from there? Zabari?
You can do
Good. The opposite of A over B, and then put it in simplest form. So what is that in simplest form? It's 4 over 3. 4/3. But it's not 4/3.
Oh, wait, no, I know.
So now the slope of this line is 4/3, but I am trying to find a perpendicular line. So I don't write a line with 4/3 as my slope. What's the slope of my new line going to be? Alyssa? -3/4. So the word perpendicular tells us to do this. Let me go back a second. This became 4/3. But we need a perpendicular line, so we flip the number, flip the sign. Now the rest is the same. We've got the slope, we need the y-intercept, then we can write our equation. So we can find the y-intercept the same way we've been doing over the past 3 questions. We use y equals mx plus b, and we plug in what we know. We have this point right here. 7 equals -3/4 times -7 plus b. Solve for b. It's a little messy, but you should be getting used to this. I've got 21/4 here. That's pretty messy. I can either convert that to a mixed number to make my life a little bit easier, or I could convert this to fourths. That might make it easier too. That's 28/4. So now when I subtract from both sides, it should be a little bit easier. So what's the y-intercept going to be for this? What's the y-intercept? Tristan? Not 1. Missed by 1 digit. Sebastian? 1 3/4. It's 7/4. When you subtract 21/4 from both sides, you get 7/4, which is 1 3/4. And so now we're ready to write our equation of a line. -3/4 x plus 1 3/4. And so we have written the equation of a line perpendicular to the original line. Yes, 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 and yes.
Could 2 perpendicular lines have the same y-intercept?
Yes. Very good point.
Just explain again how you got 28/4.
Okay, how did I get the 7 so that it was 28/4? Well, the reason I did it was because I knew I was going to have to deal with these fourths over here. But 7/1, how can I get that to turn into fourths? So what did I do to get from the 1 to the 4? What did I do, Kamoy?
You multiply the 1 by 4 and then you multiply the 7 by 4.
That's right. You multiply the bottom by 4 and you get that. Multiply the top by 4 and you get 28. Yes, I did it quickly, but again, these are the kinds of things that you should have instincts about or should be on your way to developing instincts about. Okay? Good. So let's continue to develop and improve on the idea of writing a perpendicular line. Oh, yes, I missed some questions. I apologize. Alicia, Brandon, and then Sharif. I apologize. Let me go back. Alicia, yes.
In the equation before you made it perpendicular, wouldn't the 3y already be negative? Since it said minus 3y.
You're talking about how I got from here to this?
Yeah, because it's minus 3y.
Yeah, that's why I put -3 here. But the formula for the slope from standard form is the opposite of A. So A is 4, so I wrote the opposite of A over B. But a negative over a negative is a positive. Am I answering your question? You sure? Okay. Brandon?
When I do your the equation that's needed, I can figure that out. I can make it better converting it to y equals
That very well could be a lot easier. Keep doing it.
Okay, I was about to say about you know how we have 4x minus 2y? You do like the opposite of a over b, so you change it to the opposite, right?
That's
And
right.
then when you find the opposite reciprocal, you're changing it to an opposite again. So for the a over, so couldn't you just do, you could do like a over b, and then you can just flip it around.
When you're doing perpendicular lines?
Yeah. So it's b over b.
Well, if you're going to go that far, then you could just do B over A.
Okay.
What's B?
-3,
What's A?
4. Thanks.
Okay, so again, that was good. So let's continue to develop the idea. So we're trying to write an equation of a line, slope-intercept form. I need the slope, the y-intercept, and then I can write my equation. The purpose of this given line is solely to give me the slope. That is the whole purpose of it. It has no purpose beyond that. So I'm just supposed to find the slope from here. But I'm doing a perpendicular line. So what is my slope going to be? Anissa, how'd you get that?
It has to be a negative reciprocal, so you change the sign and change the numbers.
That's right. So the slope of this line is -1/4. So she simply flipped the number, flipped the sign, and so the slope of our new line is going to be 4, and now we just need the y-intercept. So we continue to follow the same process. Plug in what we know. 7 equals 4 times -6 plus b. What will the y-intercept be? Tristan? Yep, it's 31. So now we're ready to write our equation. Y equals 4x plus 31. And so, this is a perpendicular line to the one that was given to us. Does anyone have any questions on how this was done? Good, you guys are doing well. Let's see how you do on your own. yes or no question. You had a 50-50 shot, but of course you have to prove your answer. But before we get to that, I'm just going to get the answer by surveying the class. Give me a thumbs up if you think they are perpendicular. 3, 6, 7, 8, 9, 10, 11, 12. Put your thumbs down. Half the class thinks it's an even divide. Half the class thinks it is perpendicular. Half the class thinks it's not. They are perpendicular. So I threw a wrench into the works. I asked a question that was completely unlike any question you've seen so far today. Could someone tell us what you needed to answer the question? What did you need to answer the question? Catalina?
You needed the slope.
You needed the slopes, that's right. Sebastian, did you say yes?
Yeah.
Okay, how did you figure it out?
For line A, I divided everything by 3.
Very nice. And you got what? Y equals 2/3 x minus 1/3 when you divide everything by 3. But what Catalina is saying is you really needed that. But doing what Sebastian suggested gets you that in one step, in this case. And then Sebastian, for line B, what did you do? Divide everything by 2, and you got y equals -3/2 x plus 21/2 or 10½, either way. But we don't even care about this because, as Catalina said, we are looking for this. If they are negative reciprocals of each other, then they're perpendicular. If they're not, then the answer is no. Come on.
When you like make did you with versus like for B, there's like if you go if you run 2 and rise, then you go down 3,
Yeah, if I had made the picture a little bit nicer, you would have been able to figure it out. Yeah, it looks like there's a point here, and then there's a point here, so you could find the slopes, but the picture was a pretty low quality picture. So it was...
What?
I'm sorry, just remember I have my dad's Kaloy, and you just called her local. I'm sorry, Mr. Gallen. I'm sorry, Mr. Gallen.
It's all right.
Sorry.
No, this is great.
I'm sorry.
No, it's fine. This will be enjoyable for the millions of people on the internet who will watch this. Recording it.
Wait, what happened?
Okay. So,
Wait a minute, what happened?
I want to hear. I want to laugh. I like to laugh.
okay.
We know that.
So let's move on. So lastly, we're going to finish up with basically putting everything together, and the checkpoint actually leads us into this question. I threw the checkpoint out there kind of to trip you up a little bit. I did that kind of on purpose. I wanted to see if you were paying attention, if you were really reading and understanding what it is we were looking for. Now I'm going to be a little bit more explicit. We have a family of lines. There's 3 lines. We have to figure out, are any of them parallel or any of them perpendicular? So to do that, what information do we need from them to make that determination? Catalina told us a moment ago. Someone else can refresh. Should I call on you? Okay, go ahead. Yeah, if I can have the slope of A, the slope of B, and the slope of C, and look at them, I can tell you whether they're parallel, perpendicular, or nothing at all. So that's what we want. So if we just organize ourselves, line A, and then line B, and line C, and figure out our slopes, then we can just compare them. So let's look at A. What will the slope be for line A? should be getting pretty good at looking at standard form and pulling out the slope most of the time. Brian?
So for line A is 1/3.
1/3. It's the opposite of A over B. So we see that already. Line B. What's the slope of line B? Shouldn't be this much hesitation with line B. Line B is the easiest one. Kayla? -3? Question mark? No, you should have confidence. It's -3. This is slope-intercept form. Boom, it's right there. So what could you already say about lines A and B? Can someone already make a statement about them? Hezekiah? They are. Very good. But let's continue to line C. What's the slope of line C? Alicia? -1/3. Let's see. It's the opposite of A over B. So what's the slope of line C? It is 1/3. Very good. So now let's make statements about all of them. So give me one statement. One statement. Zavari?
Line A and C are parallel to.
Very good. That was a beautiful statement. Give me a different statement. Sebastian. Line A and B are perpendicular, and Hezekiah also shared that one with us also. Give me another statement. There's another one in there. Kamoy? Good, and I love the way she said also perpendicular, because there was another one. Very good. So we can determine the relationships between the lines. Outstanding. Are there any questions on how we did this? Good, you guys are doing a great job today. Draw a line across your paper. Your classwork is page 53. You're going to do numbers 16, 14, 11, 9, 6, and 2. Okay. So now I know it was a lot, so don't stress. I expected hard work for about 12 minutes. You worked hard. So you grade what you completed. The most important question was the first one. So, I know it's a little small. The part A of the kite was y equals 2/3 x plus 4. Part B of the kite was y equals -4/3 x plus 4. And they are not parallel because their slopes are not negative reciprocals of each other. And so they do not form a right angle, which is what was meant.
You mean they're not perpendicular?
What did I say?
Parallel.
I meant perpendicular. I apologize. So let me back up. This is the equation of the first. This is the equation of the second. They are not perpendicular, and therefore they do not form a right angle. I apologize if I misspoke. Number 14. Lines A and B are perpendicular. Lines B and C are perpendicular. Lines A and C are parallel. Number 11. Y equals -5/2 x plus 14. That was the equation I was looking for. Number 9, y equals 5x minus 22. Number 6, y equals 1/2 x plus 31 halves. If you put 15.5, that's the same thing. And number 2, y equals 2/3 x minus 4. So hopefully you did all right. I am a little bit short on time, so what I will offer is you're going to go home, you're going to work on the homework assignment. I'm going to put it up in a second. You're going to try your hardest. We don't have class again until Wednesday. There's no school on Monday. So you come to my care class Tuesday morning or Wednesday morning, although it should be done by Tuesday. You shouldn't wait until Tuesday night to do it. But Tuesday morning or Wednesday morning during care, open for you guys anytime you need. I do my best to get to everybody. So if you are struggling with this content, that is totally reasonable. But do something about it. So come in the morning if you need to. Here is your homework. Page 328. You are doing numbers 4 through 28 even. Then you are doing 32, 34, and 38. That is a total of 16 questions. Read the next section, and then your next assessment is a test, which will be chapter 5, but it's not for 1.5 weeks from now. I'm just giving you a heads up now so that you can start